Thank you for the introduction, Kerry, and thank you to Marine Energy Wales for allowing us to present and also putting on a great event. So Marine Power Systems is developing the wave sub, and our mission is to deliver low-cost wave energy from ocean waves. Today, I'm going to give you guys a quick overview of where we are as a company. I'll start with a quick introduction for those of you that don't know that much about MPS. Then I'll bring everyone up to date with the quarter-scale wave sub prototype, which is currently in progress, and then a little bit of a chat about our plans for full scale and how the very early work towards that is going. So to start, I guess what we've recognized at MPS and what we think is really important is that any wave energy technology developer properly recognizes the challenges involved in delivering energy from ocean waves. So the four key challenges that we talk to are the energy capture, because ocean waves are actually quite a difficult source of energy to extract. The survivability, obviously, is self-explanatory, but very, very difficult environment at times with severe storms. Transportation, operation, and maintenance, this has to be as straightforward as reasonably possible in the ocean environment. I think nothing's particularly straightforward at sea, but we feel you need to make it as easy as it can be. And of course, capital costs. There's no point in achieving solutions to the first three challenges if you can't actually do it at a sensible price. So we believe that many devices actually fail to meet all of these challenges, but we also believe that the wave sub really does address them fundamentally. And just to put those into context, obviously it's easy to list a load of challenges, and they could sound a bit esoteric, but I think these challenges really do get to the crux of what we're all trying to deliver here, which is competitive, levelized cost of energy. And all of those things I talked to, they all appear in the equation. They either put the capital cost of the device up if you don't do it, or they put the operation costs up. And of course, energy capture is the other half of the equation, and it's really important to capture as much energy as possible from the structures that you invest in building and installing in the ocean. So just to explain a little bit more about how the wave sub works, I'm just going to refer to our animation. That's the easiest way to do that, so I'll just play that now.
Wave sub is a revolutionary new device that has solved all these challenges and is on course to be the world leader in the capture of wave energy. Wave sub can be easily transported across the sea and installed with the simple connection of the moorings and power cables. Harnessing the entire orbital motion of a wave, the wave sub is highly efficient in generating power. It sends power to the local grid network through an undersea cable. Wave sub automatically adjusts its depth to allow optimal power generation depending on sea conditions. It can descend completely to protect itself from storms. Wave sub is straightforward to maintain. It can be returned to the surface, where it can be accessed for maintenance, or it can be disconnected and transported to shore for major servicing. Each wave sub generates 5 megawatts of low-cost power, enough to power around 5,000 homes. A large farm of wave subs would cut CO2 emissions by hundreds of thousands of tons over its lifetime, powering around 500,000 homes with affordable, reliable electricity. That's more than enough power for a city the size of San Francisco. The oceans remain the last untapped renewable energy resource. Waves can provide 10% of the planet's electricity by 2050. The world is at a crossroads. Join us. Choose to transition to 100% renewable energy.
Okay. So to bring everyone up to date with where we are with our quarter-scale prototype, I've got a few slides on how that's going. So where we've got to is we've completed the manufacture, we've launched the device, our test program is now underway. So we've done testing up to date, it's been in Milford Haven, we've done all our dry commissioning, submergence testing and tow testing. We're currently commissioning the power buoy and making sure that that communicates with the device effectively. And in May, we'll be towing the device down to fab test in Falmouth. And from May onwards, we'll be generating energy with the device. Fingers crossed, of course, but everything's going well so far. Just a little side note, we've been delighted to have been funded by WEFO, and there's a little before and after image of the sort of how we envisaged the device when we started that project, and then how it looked in the actual deployment. I must admit the blue boat is a fluke. We didn't ask Williams Shipping to repaint their entire fleet just so the hour or so we spent on the image we wouldn't have to do it again. We're looking forward to working with WEFO again on our full-scale project, and hopefully they see that we've delivered what we said we're going to do on this project. So the deployment, we manufactured the device at Lead with mechanical engineering and deployed it off the quay right at the end of last year, so it was a big rush on in MPS to get this in before Christmas. Everyone was delighted then to go home for Christmas knowing that we'd actually finished the device, it was in the water, and it was safely towed over to Milford Haven where it spent its Christmas break. So just a few nice shots there of us towing across the haven. So we've also carried out submergence testing. So all the equipment on board the device is all fully automatic. This is operated from a box on the shore. You can connect wirelessly to the device, so the device was deployed and then recovered remotely. So all the buoyancy system and the power systems are all working fine. And we also carried out tow testing. Obviously, towing down to Falmouth is it's a long tow, so we need to make sure the device is seaworthy. And of course, this is one of our fundamental USPs. You know, we really believe that being able to tow these devices easily, maintain them easily is super important. If you look at offshore wind at the moment, the devices or the sort of equipment needed to install them is €250,000 a day for the really big stuff. So, you know, it's really important to get that cost down. So just running a quick video there. And as you can see, WaveSub is just perfectly comfortable being towed, and we're happy now that we can tow down to Falmouth and not be too worried about it having to be absolutely flat calm. And so the weather window has expanded nicely for that. When we get down to Falmouth, we'll be deploying at Fab Test, and that's a site, really it's just at the moment, it's nothing more than an area on a map, but we'll be deploying there with a full set of marker buoys in May. And that's how the WaveSub will look when it's installed. We have our own power buoy, and that is where we'll be delivering the power from the WaveSub to the power buoy. The power buoy has its own onboard microgrid, so the WaveSub at quarter scale is fully able to supply energy to the grid. So we've learned all those lessons around how to export grid-compliant electricity from the device. We also have a fully developed control system that can be remotely operated from shore. So we've got ourselves a long way up a lot of learning curves with our quarter scale machine. So just to touch on the supply chain theme of the session, I've just here listed the supply chain in Wales only, but there's obviously a bigger European, British and European supply chain. But we really have, you know, we feel that we're really maturing a supply chain for the WaveSub here in Wales, and there's a lot of companies have been involved so far and many more to be involved going forward. So moving on to the full-scale project. So with we've still got a little bit more to do, but we'll soon be in a position where we'll say the quarter-scale prototype has been a success, and then that will allow us to move on to the full-scale machine. So we're looking at making some improvements. So I'll talk to you about the concept design progress, also the tank testing work we've been doing, and the computational simulation work that we've been doing. So we're going to move the concept on. Obviously, we've learned a lot from the quarter scale. We've been doing a lot of work in the background. The main sort of goals for this work will be reducing the structure size per megawatt, and we've worked out how to dramatically reduce the amount of structure, but also increase the amount of power. We'll be improving the PTO, we'll be improving the mooring, and of course, bringing all the other sort of more lessons around, you know, seaworthiness and the practical things from the quarter scale as well. And there you can see that two of those goals with reduced structure size per megawatt and increased power capture, that's where we're looking also towards a multi-float concept for the full-scale WaveSub. So this is a quick insight into the simulation work that we're carrying out on our full-scale machine. This is a WEXIM simulation of a single-float WaveSub. We've reduced the size of the reactor, we've improved the mooring, and this particular animation shows irregular waves at 3 meters with a 12-second energy period. We do these animations not just to show pretty pictures at conferences like this, which is it's nice, but it's absolutely vital that this visualization process is carried out. Otherwise, you can't be sure of what the simulation is telling you. We've seen simulations where we've had fantastic energy capture, but then we look what the simulation is doing, and it's got some wild movement on it that's completely impractical. So this visualization step is vital in accumulating reliable simulation data that you can actually use to make good decisions on. So just another little snippet. This is a power matrix from that exact simulation, or rather, that exact simulation makes up 1 point on this power matrix. You can see there that it might not be that clear, but in very sensible seas of 5 meters or less, the device is producing over 1.3 megawatts. So even with a sort of 75% conversion efficiency, we're looking at a device that's clearing over a megawatt in a 5-meter sea. That parametrics doesn't really reflect any tuning. We will be doing a lot more tuning work, and that will effectively plump out that parametrics. It won't change the peak so much, but it'll be across a much broader, the peak will be a lot broader. And yeah, we're working, as we speak, we're working on it. This is work that's ongoing right now. But the next step is really then to start looking at more advanced control algorithms like adaptive control, wave-by-wave control, and then that could lead to an uplift across the entire parametric. So everything that we're showing here is on the very conservative side of what the machine is capable of. So we also talked about the full-scale, the multi-float wave sub. So this is a simulation of that's from work we're doing with Swansea University, where we have a PhD student looking at simulating a multi-float array-on device. So it's not very obvious, but what is unique and really leading the field about this work is that all 3 floats and the sea surface are coupled in this simulation. So if you look sort of between the floats, you can see that the sea surface is changing, and you can see the color changes. So we're actually simulating the effect that the floats have on each other and how they interact. And this will give us a huge advantage when it comes to designing an effective multi-float device. Effectively, as I said, creating an array on one device, and this can then allow the wave sub to be a true multi-megawatt machine, easily arrival to the very largest offshore wind turbines that are currently being deployed. And it's important to say, of course, simulations are exactly that, they're simulations. So we back up everything we're doing in the computer with tank testing work, and this is a little animation of some of the tank testing that we've recently done with the Plymouth Ocean Basin. So again, everything is verified, and we're confident in the steps we're taking to make sure that we make the best possible decisions about how a full-scale wave sub will look. And again, just coming back to the supply chain theme, we're very excited about the plans for Milford Haven Port. That's a great piece of infrastructure that we're really looking forward to taking advantage of, and Tim James from the port will talk about that a lot more later on this afternoon. So that was it from me. Thank you for your attention, and I think we do questions afterwards, but I'll welcome any questions later on.
We'll take questions at the end, if that's okay. I'd like to give all the panel a chance to have their go first. Thank you. Thank you very much, Graham.